for section 3.1, we are going to be analyzing the graphs of quadratic functions in both standard form and general form. So we're going to go ahead and get started with looking at the definition of the quadratic function in standard form, which is basically something similar to what we did in the transformation section. So the quadratic function f of x equals a parenthesis x minus h squared plus k. Now the first thing that you need to know is that these two values will give the what is called the vertex of the parabola. Now the vertex, whenever the parabola is graphed, it is going to be represented by the center of that parabola. That's what is going to be my hk, which is the vertex. Okay, that's what it is. Now just know one thing, that on your vertex, the value of x, according to the transformations, remember that it goes in the opposite direction. That value of x is going to change the sign, meaning that it's going to be the opposite sign, right? And the value of y is going to stay the same. That one, if it's a plus, that one goes up. If it's minus, it goes down. That's what we covered in the transformation, so that one stays the same. Now, the parabola is symmetric also. Symmetric with respect to its middle line right here. Anywhere where the middle of the parabola is located, that's what we call the axis of symmetry, or line of symmetry. And that line of symmetry, as you can see by the picture, it is a vertical line, and a vertical line has an equation of x equals to a constant. Okay, in this case, that x will be the same x as the value of the vertex, which is x equals h. That's what it tells you on the next part. So the parabola is symmetric with respect to the line x equals to h. And one last thing that you need to consider is this number in the front, which is a, if it is greater than 0, meaning that if it's positive, the parabola opens up. If that number in the front is less than 0, meaning that if it's negative, the parabola opens downward. These are the general concepts that you need to know from the quadratic function in what we call standard form. Now, let's answer the first question here, which is we are going to look at this graph of this parabola, and what I want to do is there is no choices, so we're just gonna go through creating the equation ourselves. So we want to get an equation for this parabola that is being graphed. Okay, and we're gonna write it in standard form. Now, one thing that I want you to do based on the choices originally given is that you need to assume that a is equal to 1. Okay, so basically the equation that we're gonna try to find, the function, I'm just gonna say f of x. Let's call it f of x. It is going to be no a, I'm just gonna put x minus h squared plus k. So remember, what does the h and the k basically represent? It represents the vertex. So the only thing we actually need to determine to get the equation here is we need the vertex of this parabola, which in this case the vertex is going to be 3, negative 3. Okay, remember when we set it up, on the x value is going to be the opposite sign of the x value of the vertex. So right here is going to be x minus, this one is a positive 3, so it's going to be x minus 3 on the equation, square, and then the y value of that vertex is minus 3, so we're going to put a minus 3 on the outside. That basically is all what we need to do to get the equation of this parabola. Now, working with the vertex, next thing we're going to do is this. I want you to, in this following exercise, I want you to give me the coordinates of the vertex of this quadratic function. F of x equals to negative 3 parenthesis x plus 5 squared plus 6. So, according to the definition, the vertex will be given by the opposite of this value, which is going to be negative 5, and this 6 is going to stay the same. That's going to be my y value. So the vertex of this parabola is going to be located at -5, positive 6. Okay. Now, let's get to the main idea of this section. The main idea of this section is for us to graph quadratic functions by analyzing all of its attributes. What do I mean by attributes? Several things. Number one, the direction of opening of the parabola, meaning if it opens up, if it opens down, and that we determine it based on the sign of the A value. Second, the vertex. Okay, so determine whether the parabola opens upward or downward. Next thing is the vertex, HK. Third thing, analyzing the x-intercepts of the parabola. Now, to find the x-intercepts, just like we did on the previous section, we have to set the f of x equals to 0, which is your y, and then solve for x. So that's how we find the x-intercepts, or the solutions of the equation. Okay? Or the zeros, or the roots. And the next thing is we need to analyze the y-intercept. To find the y-intercept of any equation, we need to substitute every x in any equation with a 0 to find the y-intercept. And then we're going to plot the intercepts, the vertex, and any additional points as necessary to create the graph. So this is the strategy we're going to follow to create the sketch of the quadratic function. Now, let's go ahead and get started with this question here. Use the vertex and intercepts to sketch the graph of the quadratic function. And then it says, use the parabola to identify, give the equation of the axis of symmetry, and use the parabola to identify the domain and the range. Alright, so let's work on this right here. The first thing that we are going to do is we're going to identify the vertex. Based on the definition, the vertex is going to be the opposite of this number, which is going to be positive 1, comma, and this number stays the same, that's negative 2. So that means that the center of my parabola right here is going to be located right here at this point. Next, we can also find the axis of symmetry already. How do we find the axis of symmetry? Remember that the axis of symmetry is going to be the same as the value of x of your vertex. It is a vertical line, so we're going to label it as x equals to positive 1. That's the equation of a vertical line. So when you sketch it in your graph, go ahead and make it a dotted line or dashed line. Okay? So because that's not my graph, it's just the line of symmetry. That's the middle of my graph. Okay? Now, the next item that we're going to find here is the y-intercept. How do we find the y-intercept according to the definition? We need to go to the function f of x equals 3 parentheses x minus 1 squared minus 2, and we're going to substitute every x in this equation with a 0. So that would be 3 times 0 minus 1 squared minus 2. And let's evaluate this. Let's simplify it. So first of all, the parentheses. 0 minus 1 is negative 1. And then if I square that negative 1 times negative 1 is going to give us a positive 1 right here. Then we are going to multiply times 3. So that's going to give us a 3 minus 2, which is going to be a positive 1. So that's my y-intercept. Now, let's get used to this of writing the y-intercept as an ordered pair. So the y-intercept as an ordered pair would be 0, comma 1. When x is equal to 0, y is equal to 1. So it's going to cross the y-axis up here at 0, 1. Automatically, something that we can tell, if you remember, is that since the parabola, now since 0, 1, it is a point on the graph, we can also say, because of the axis of symmetry, that the point on the other side of this line at the same distance as this one, it is also going to be on the graph, which is 2, 1. Okay, so because this is a symmetry, so it has to be reflected over. Okay, now we can already sketch it with those 3 points. However, just to be more specific and more detailed, that's what this section is about. We're going to do some extra things, which is we're going to find the x-intercepts of this function. Now, to find the x-intercept or intercepts, what we got to do, again, we're going to go to the function f of x equals to 3 times x minus 1 squared minus 2. We got to set the f of x, which is the y, equals to 0, and solve for x. So, in this equation, if I want to solve for x, what we have to do is, the best method for solving will be the square root property. And I mentioned to you the y on the previous section. And the reason is because this equation only contains one x on this quadratic equation. So the best way would be using the square root property. So what I'm going to do is, again, I'm going to first leave that parenthesis by itself by adding the 2 over to the other side. So this is going to give us 2 equals 3 parenthesis x minus 1 squared. Then what we need to do next to solve for x is that we need to divide the 3 that is on the outside. So we need to get rid of that 3. So it's going to give us 2/3. So I'm going to continue it up here. So it's going to give us a 2/3 equals x minus 1 squared. And then just like I showed you before, to get rid of that square, we need to take the square root on both sides. The square and the square root, they simplify, and we have to put a plus or minus. That's the square root property. So that's going to give us plus or minus 2/3 equals to x minus 1. I don't need the parentheses anymore. To x minus 1. And then to leave the x by itself, I'm going to add the 1 to both sides. And that's going to give me 1 plus or minus the square root of 2/3. That's going to be my x. Now, since the 2/3 it's not a perfect square, of course, and we know for sure that the two solutions that we're going to get, they are going to be irrational. So, using the calculator, let's find the estimates of these two solutions. So, using the calculator, we're going to have, we have a 1 plus and 1 minus. So it's going to be 1 plus the square root of 2/3. That one is going to give us a 1.8 approximately. And the other one, 1 minus the square root of 2/3, it is going to give us 0.2 approximately. So this one is going to be approximately 1.8. I'm just going to put them right here, 1.8. And the other one is going to be 0.2. So if we try to be more specific, if you want to sketch them, 0.2, it is somewhere on this area, and 1.8, it is close to this number 2 right here on this area. And the symmetry still applies to these two, as you can see. So we're going to create the sketch of the parabola, opening of course on both sides and continuing up to this side, and also continuing up to this side. Okay. Now we got to give a couple of more things on this parabola. The last two items that we need to find is the domain and the range. Now for domain, remember that since this graph keeps on going to the left side and it keeps on going to the right side, all the negative values of x will be on the graph of this function, and all the positive values of x, since it continues, will be on the graph somewhere at the top of this function. So that means that the domain is any number from negative infinity all the way to positive infinity. Now, the range of this function, the lowest value in this function is -2. So that is my lowest, and it is included because it starts from -2. And then the highest value, it is going to be positive infinity, because, like I said, also the graph keeps going all the way up, meaning all the positive values of x all the way to infinity will exist on the graph of this function. Okay, so it would be -2, to positive infinity. And this concludes the analysis of this function. Next, the next item in the agenda, it is going to be analyzing quadratic functions in the form ax squared plus bx plus c, which is called the general form. Now, if a quadratic function is in the form of ax squared plus bx plus c, to find the vertex, we're going to use the formula negative b over 2a, comma, f of negative b over 2a. Meaning that if I want to find the x coordinate, that this is the x coordinate, I'm going to use that formula to find the x value. And what does it mean by f of negative b over 2a? Whatever I get for that x, I'm going to substitute it. That's what the f of negative b over 2a. Find the value of y at when x is negative b over 2a, meaning replace that answer into the x's of this function to find the y value. That's basically what it tells you here. To find this y value, you're going to substitute the x value into the equation to find the y value. So let's go ahead and get started with first finding the vertex. We're going to use this question here. In the following exercise, we're going to find the coordinates of the vertex of the parabola defined by the given quadratic function. We got f of x equals 3x squared plus 18x plus 6. Now, to find the vertex, first of all, we're going to find a and b. We don't need the c in this problem. A is the number in front of the x squared, which is 3, and b is the number in front of the x, which is the 18. So, to find the x coordinate of the vertex, we're going to use the formula negative b divided by 2a, in which the b is 18 right here, divided by 2 times a, and a is equal to 3. So if I simplify this, that's going to give us a negative 18 divided by 6, which is going to be a negative 3. So this is the x coordinate of the vertex. X is equal to negative 3. Now, how do we find the y value? All we got to do is replace that x value into the function f of x. So we're going to replace every x with a negative 3. So that would be 3 parentheses x, which is negative 3, squared, plus 18 times x, which is negative 3, plus 6. Then we simplify this. So that gives us, first of all, I'm going to do the exponent here. So that's negative 3 squared is going to be a 9. I'm going to multiply these two. 18 times negative 3 is negative 54 plus 6. Then the 9 times 3 is a 27. So that gives us a 27 minus 54 plus 6. And that gives us a negative 21. Because 27 minus 54 is negative 27 plus 6 is negative 21. So what does this mean right here? This means that the vertex for that given quadratic function, it is going to be the point when x is negative 3, y is going to be negative 21. And this will be the vertex. Next, just like on the other standard form, we're going to actually do the exact same thing on these functions. We're going to analyze them. How do we analyze the attributes of the function? By doing the exact same thing. The direction of opening, that's good to know. Again, the question is not asking for that, but again, it's good to know where the parabola opens, if it opens up or down. Okay. Now, we're going to determine the vertex by using the formula that I show you just right now. Then we're going to find the x-intercept by setting the y equals to 0. We're also going to find the y-intercept by setting every x equals to 0. Okay? And there's one little thing that you will find out once we get to the graph. Okay? I'll explain that in a bit. And then we're going to plot the points that we found and any additional points as needed. Now, additional points are needed when you have less than 3 points in the parabola. To graph a parabola, you at least need to have 3 of the points. Okay, so let's go ahead and graph this one right here. We're going to use the vertex and the intercepts to sketch the graph of the quadratic function. We're going to give the equation of the axis of symmetry, and we're going to determine the domain and the range. Okay. So the first thing that we should know about this problem is that it is the function, it is not in the correct notation. So in order for it to be in the correct notation, it has to be in the form ax squared plus bx plus c. So we need to switch these two over their positions so we can rearrange them. So my function is going to be negative x squared plus 8x minus 7. Now we can say that a is equal to negative 1, b is equal to 8, and c is equal to negative 7. So to find the vertex, the first thing we gotta do is we need to find the x value with the formula negative b over 2a. So we're gonna substitute. The b is 8, so it's negative 8 over 2 times a, which is negative 1. That gives me negative 8 divided by negative 2, which is gonna be positive 4. So that is my x value. And now remember one thing. If I want to find the y value, what I need to do is I need to replace that x equals 4 into the function, into every x. That's what I'm going to do next. So that's negative and then x, which is 4 squared, plus 8 times x, which is 4, minus 7. And then we simplify this answer. So we're going to get negative 4 squared is going to be a 16, but then times that negative on the outside is going to make it a negative 16. 8 times 4 is going to be plus 32, and then minus 7. If we simplify this, we are going to get negative 16 plus 32 is positive 16, minus 7 is going to give us a 9. So we're going to give the coordinates of the vertex right here. So my vertex for this function, it is going to be the point 4, 9. So let's go ahead and sketch it right here. So the middle of my parabola is going to be located right here at 4, 9. Also, one more thing that we can know already, which is the axis of symmetry. Now we already know that there's going to be symmetry exactly where the vertex is. That is going to be the middle of the graph. So that would be at x equals to 4. That will be the line of symmetry because it is a vertical line, so the equation is x equals. So we're going to graph that with a dashed line right here. This is where my symmetry is. Next, now we're going to find the y-intercept. To find the y-intercept of any function, we're going to set every x equals to 0. So we're going to go to the function here, f of x equals negative x squared plus 8x minus 7. And we're going to set every x equals to 0. So that would be negative 0 squared plus 8 times 0 minus 7. And if I evaluate it, then negative 0 squared is just going to be 0, plus 8 times 0 is going to be 0 minus 7, and that gives me an answer of negative 7. So I want you to make one little observation here on the y-intercept. Now, as you can see, the y-intercept, whenever the function is in the general form ax squared plus bx plus c, the y-intercept will be the exact same thing as the value of c. Okay. So 0, negative 7, that's where the graph is going to intersect the y-axis. Now, what can we say? Since there's symmetry at x equals to 4, then we can also say that the distance from here to here on the graph must be the same as the distance from here to here on the other side. So there must be another point here at 8, negative 7. 8, negative 7. That should be another point of the graph. And we can already sketch it, but to be more specific again, I just want to know where exactly it's going to cross the x-axis. So let's go ahead and find those last attributes, which are the x-intercepts. Now, to find the x-intercept or intercepts, we have to set the f of x of this function equals to 0. That's what we're going to do. So if I set the f of x equals to 0, we're going to get 0 equals negative x squared plus 8x minus 7. And the first thing that we're going to try to do, since this is a trinomial, I'm going to try to solve this equation by factoring. If factoring doesn't work, then we have to go and base ourselves through the quadratic formula in this one. So to factor this one, the very first thing, remember I mentioned to you before, is that the number in the front cannot be negative. So what we gotta do first is factor a GCF, greatest common factor of a negative 1. That is my GCF here. So we're gonna factor that negative 1, and that's gonna change the sign. So it's gonna become x squared minus 8x plus a 7. And then we can factor that trinomial by multiplying a times c. Now since a is equal to 1, I don't really need to multiply because it's not going to make any effect. 1 times 7 is just going to be that 7 at the end. So if a is equal to 1, you don't account it for. So we're going to find two numbers that multiply give me 7, and right here this means that when added they give me 8. So it's going to be 7 and 1, but it is a negative 8, so both of them are supposed to be negatives. So we're going to open the two parentheses for the factors. The x squared, we divide it evenly. And then the negative 7 or negative 1 or negative 7. Or negative 7 and negative 1. Okay. Right here, again, that 1 is not going to have any effect. So we don't need to divide by 1. So then we find the solutions by setting them equal to 0. So this one gives me x equals to positive 1. Remember that it changes the sign. And x equals to positive 7. Those are going to be the x-intercepts of this function. So this function crosses the x-axis at positive 1 and at positive 7. So when we go to the graph, this is where it's going to cross the x-axis. Right here and right here. And you see that's exactly the same thing with the symmetry. The distance from here to the axis of symmetry must be the same thing as the axis of symmetry to this point right here. Now let's go ahead and connect this parabola with a bowl shape. So we're going to have it from here going, let me change the color here. Didn't change it. From here going down here and then intersecting the y-axis at the 7 right there. Okay. So that is going to be what the graph is kind of going to look like. There it is. Okay, and the same thing is going to happen on this side. So it's going to intersect the x-axis right here at 7, and then it's going to keep on going, passes through here, and it keeps on going. Okay, so those are all the attributes for this function. So don't forget that we have two more things to give, which is the domain of this function and the range of this function. As we can see about the domain, the graph is going to keep extending indefinitely to both left and right. So that means that all the negative values of x will have a point on the graph, and all the positive values of x right here are going to have a point on this graph. So what does that mean? That the domain is going to include any number from negative infinity all the way to positive infinity. Last but not least, for the range, this graph keeps on going all the way down, which means that the lowest value of y on the graph will actually be negative infinity. There's no lowest value, it keeps on going down. But the highest value on this graph is going to be positive 9 right here, including the positive 9, so it's going to be with the square bracket. And that concludes this question on the analysis of this function right here, f of x. We have a couple of more things on this section to discover. Now, without graphing, we're going to be analyzing the domain and the range of the function, and also the equation of a function, just by looking at what is called the minimum and the maximum. Okay. Now, just know this we already talked about it. If the value of a is positive, we said that the graph of the parabola opens upward. If it opens upward, then the vertex is going to be called the minimum point of the graph, because it's going to be the lowest point on that curve. On the other hand, if the value of a is negative, then we already mentioned that the parabola is going to open downward, meaning that the vertex is going to be the highest point in the graph. So in this case, we call it a maximum. And that, of course, that minimum or that maximum, as you can see, it is going to be actually the vertex of the parabola. Okay? So we're going to analyze finding the equation of a parabola, just by given the maximum or minimum, and which is, we just keep in mind that it basically represents the vertex. And also we're going to be finding maximums and minimums of parabolas and domains and range without having to sketch the graph. Okay. So last two questions. Let's go ahead and work on this first. On this problem, what we want to do is we want to write an equation of this parabola in standard form of the parabola that has the same shape as the graph of f of x equals to 6x squared, or g of x equals negative 6x squared, but with the given maximum. Okay, so that maximum means the following: that the parabola right here opens downward, and that maximum occurs when x is equal to 2 and the maximum is 1. So that vertex, basically, it is going to be the point negative 2, 1. And now, what do we know about the parabola if it opens up? What do we know about its equation? We know that since it opens down, then it's going to be a negative in the front. So we needed to decide, first of all, which one of these two is going to be the actual shape of that parabola, and because of the negative, it's going to be g of x equals negative 6x squared. So now let's go ahead and create the equation. So we already know g of x equals negative 6, but the vertex is going to be different. So we're going to open the parentheses and we're going to put the vertex. Remember that for the number inside, it is going to be the opposite sign of what we see right here. So it's going to be the opposite. So which is going to be a plus 2. And the number and the y value, it is going to be the exact same number, which is a plus 1. And that concludes this problem. This is the equation of this parabola that has a maximum of 1. This is my maximum when x is equal to negative 2. And that's basically it. And it has the same shape as negative 6x squared, of course. Last question that we're going to analyze here, it is going to be the following. Let's see. I pick one. Let's do this. Consider the function 2x squared minus 20x minus 8. Without graphing, what we need to do is we want to determine if the function has a minimum value or a maximum value. How do we know that? By looking at whether the parabola opens up or down. If you look at this one, since a is equal to 2, then that means that this parabola opens up, and in that case, that means that the vertex is going to be a minimum point. Right? So this parabola has what is called a minimum value. That's the answer for letter A. Now, what does that minimum represent? The vertex. So in letter B, to find that minimum, all we need to do is find that vertex. Okay? So that's for letter B. Now to find the vertex, first of all, we're going to find the x value by doing the formula negative b over 2a. Knowing that a is equal to 2, b is equal to negative 20. Right? So we're going to have negative b, which is negative 20, divided by 2 times a, which is positive 2. and that gives me a positive 20 divided by 4, which is going to be a 5. This is going to be the x value of the vertex. Now, to find the y value of that vertex, all I got to do is replace that 5 into the function. So it's going to be f of 5 equals 2 times 5 squared minus 20x, which is minus 20 times 5, minus 8. Let's evaluate it. So 5 squared is going to be 25. And then negative 20 times 5 is negative 100, minus 8. Then we can multiply these two values here. 2 times 25 is going to be 50. So 50 minus 100 is going to be negative 50. Minus 8 is negative 58. So this is what we're going to say. They wanted you to say what the vertex was. You know what was the minimum value? Okay, and where does it occur? So you're going to say this. The minimum is negative 58, and it occurs when x is equal to positive 5. That's the best way to describe that answer on letter B. And on letter C, and last, identify the domain and the range of this function. So right away about the domain, we know that any parabola that we graph, any function in the form of a U-shape, is going to extend indefinitely to both the left and the right, meaning that it's going to go all the way to the negative infinity on the left side to the positive infinity on the right side. All the negative values of x and positive values of x will contain a point on this graph. Now, for the range, we already know that the minimum right here is negative 58. What does that mean? That the smallest value of y is going to be negative 58, and the largest one, since it goes up, it's going to be positive infinity. And those are the answers for this problem, A, B, and C. That concludes the section on quadratic functions.